find the arc length of the graph of x equals y fourth over 4 plus 1 over 8 y squared from point A to point B, where point A has a y coordinate of 1 and point B has a y coordinate of 2. Y is our changing variable. We have to recognize that and then go with the formula that has integration with respect to y. So think of x as some function of y and go with the formula that we take the derivative of that with respect to y, square it, add 1, take the square root, and then integrate with respect to y from some a to b with a being 1 and b being 2, the different y values. Let's break it down step by step. First, let's find the derivative. Then we'll square it, and then we'll add 1. Take our function, and this y squared in the denominator, it's best to bring it up and make it y to the negative 2. Whenever you have a constant in the numerator, you can do that. It just makes the power rule be the way you want to take the derivative instead of maybe thinking about doing it as a quotient rule. Take this derivative, bring down the 4, and take y cubed. The 4 and the 4th cancel. Bring down the negative 2, and take y to the negative 3. And then the negative 2 and the positive 1/8 give you a negative 1/4. Now this is y to the negative 3. So let's go ahead and put it back in the denominator as y cubed. And you can make this a minus in between if you'd like. We've done step 1. We've taken the derivative. Part of step 1. Let's go ahead and do the second part of step 1. Let's square it. Multiply it by itself. When you FOIL this out, you'll get y to the 6th. Be careful here. You already have y cubed, and this is one reason why we wanted to put the y to the negative 3 on the denominator, so that these y cubes cancel out, and you just get negative 1/4. Going to happen again here. Y cubes cancel out, and you just get negative 1/4. And then finally you get a positive 1 over 16, and then we get y to the 6th. These two middle terms combine to give you a half, but a negative a half. So you've taken the derivative, and now we've squared it. Last thing, we need to add 1. We do it to both sides. The 1 that we add will interact with the negative 1/2 to combine and just flip it over to be a positive 1/2. And so we're done with step 1. We found the derivative, we squared it, and we added 1. Great. Now let's move to step 2. We want to simplify this if we can before we take the square root. Basically, if you could represent what you have as a perfect square, then when you take the square root, they'll cancel each other out. This doesn't always happen, but if you can, you'd like to. Now, what we had earlier was that when we squared out y to the 3rd minus 1 over 4y cubed, we got a negative 1/2. If we were to square out y cubed plus 1 over 4y cubed, we get a positive 1/2. The two middle terms would be a 4th and a 4th. They combine to be a positive 1/2. So that's exactly what that is. If you FOIL this out, the outside terms are the same, the f and l from FOIL, but the o and I combine to give you a plus 1/2 instead of a minus 1/2. And so we've done it. We've represented it as a perfect square. It is y cubed plus 1 over 4y cubed, the quantity squared. And so now we just take the square root. And because it's a perfect square, these operations undo each other, and we just get what's underneath. Okay, so we set up our arc length formula. And once again, we're going to bring this up to the numerator as a negative 3 power to make it easier to do our antiderivatives. Just like we made it easier to do our regular derivatives. And so the last step would be to go to the next slide here. Now we just integrate. So we take the antiderivative by adding 1 to the exponent, power rule in reverse, and dividing by the same thing. Y to the 4th over 4. Add 1 to negative 2, we get y to the negative 2 over negative 2. Simplify that by calling that negative 1 over 8 y squared. The negative exponents are good to take the derivative, good to help you take the antiderivative, but when it comes time to evaluate, it's just more helpful to have it as a positive exponent. So we're going to put a 2 in. then we're going to put a 1 in. Fundamental theorem of calculus says we subtract those. The second from the first, and we get our answer. Put the 2 in, we get 16 over 4. And minus 1 over 8 times 4. Put the 1 in, you just get a fourth minus an eighth. 16 over 4, more commonly known as 4, minus 1 over 32. These two together are an eighth, so we take away an eighth. Common denominator, 32. 32 times 4 is 128. Take away 1, and then also take away 4. Altogether, take away 5. Final answer, 123 over 32.